We're continuing our work with finding zeros for polynomial equations. All right, on Friday last week we had a 3-step process. What was the first step in that process?
Zeros. List.
Make the list. All right, we need to make the list. And how do we come up with the numbers for our list?
The last number goes top, the first number.
Okay, factors of the constant, right, go on top, and factors of the leading coefficient, which in this case is a 1, go on the bottom. What are the factors of 4? 1, 2, and 4. Okay, I'm going to put the 1 on the bottom, even though dividing by 1 isn't going to do anything. It does show me that I knew there was supposed to be that leading coefficient factor on the bottom. Okay, so we have 1, 2, and 4, negative 1, negative 2, negative 4. We've got 6 possible rational zeros. What's our next step? The graph. All right, we have to go to our graphing calculator and figure out what our graph suggests. All right, so let's go in here. We want to put our equation in. X to the third minus 2x squared minus 7x minus 4. All right. Now, what does this graph show me? One of my zeros looks to be 4. Yes? Is 4 on my list?
Yes.
All right, perfect. What else does it show me? It looks like it's bouncing at negative 1. Now, you do have to be careful because our window is going in the y direction from negative 10 to positive 10. So we really have a lot of space in there, and it looks like it bounces, and maybe it does, but we should double check that because it could be crossing and coming back down through the x-axis really close, and it's a little hard to see in this window. So let's look at our y values. If we change them, let's say we go from negative 2 to positive 2. All right, so we're just going to zoom in there. Negative 2 to positive 2. All right, so it still is looking like it bounces, yes? And that's what I wanted to double check. So we're going to go on our calculator here, and we're going to say it crossed at 4, and it looks like it's crossing at negative 1 with a multiplicity of 2, right? That means that's going to count as 2 of my zeros. How many zeros am I trying to find? 3, right? It's an x cubed graph. So we do want to find all 3. And we have 3 here that are nice rational numbers. So our last step is to do that prove process. We aren't missing any terms where we would need a 0. And it doesn't matter which order you prove the zeros in. Your numbers will look different than mine if you go in a different order, but it still should get you no remainder. All right, so I'm just going to go in the order I have. A 4 first. We bring down our first term, multiply these, and then we add our column. Multiplying, adding our column, multiplying, and adding the column. So the 4 does work. It gives me a remainder of 0. Now I'm going to try the negative 1. We bring down our 1, multiply, and add. And that worked. But we said it should have a multiplicity of 2. So it really should work twice. And it does. All right? So that's enough to prove that those are the 3 zeros. And if you have one that has a multiplicity other than 1, you should state that in your answer so we can tell it that you knew that. Okay? The second homework question that we're going through is number 22. All right, same process. We're going to look at a list. So I need positive and negative factors of 4. All right, so 1, 2, and 4 over factors of 2. So 1 and 2. Looking at all the different combinations I can make. 1 divided by 1, 2 divided by 1, 4 divided by 1, and then 1 divided by 2, 2 divided by 2 is 1, which I already have on my list. And 4 divided by 2 is 2, and I already have that. Okay, so there's my list. Now we're going to go to the graph and see what it looks like. All right, so we had, what was it, 2x cubed? All right, I'm going to do a zoom 6 to reset my window because we did change it last time around. And how many zeros am I supposed to be finding? 3. Do I see 3 places where it crosses? Okay. Now, if it looks like it's crossing at a point that is not on my list, that means it's not a rational answer. So when I look at this, I see something that's hitting around -1. Yes? And again, we could zoom in a little bit. Let's go from, say, -3 to 5 for our x's, so we're a little closer in there. And let's go from, we'll do -3 to 3 on this one. Zoom in a little bit. So you can tell that it isn't actually touching at -1. All right, it's close to it, but it isn't hitting at it. Now, if you hadn't zoomed in and you thought, I'm going to try -1, and you try it and it doesn't work, then you got to start over. You cannot build in your synthetic process over on something that doesn't work. Okay? So, -1 is not a solution. It does look like it's crossing between 0 and 1 at about a 1/2, and 1/2 is on my list. Okay, so I could try that. And then it's crossing somewhere between 3 and 4. I don't have anything on my list between 3 and 4. So the only one that I am going to put down, my graph is suggesting a 1/2. The other two are real answers because I can see them, but they're not rational. They're not from my list. I can still prove the 1/2 and then go from there. So my coefficients are 2, -5, -6, and 4. I'm going to go through with the 1/2. We bring down our 2. What's half of 2? All right, adding our column, we get -4. Half of -4. Adding, we get -8. Half of -8. And adding, we get 0. So we have proved that the 1/2 works. Okay? Look at what we have left. This piece right here is a 2x squared minus 4x minus 8, correct? I need to find the zeros of that. I have some options. The first thing I would probably do is factor out the 2, just to give myself some smaller numbers to work with. However, the trinomial that I'm left with, x squared minus 2x minus 4, is not factorable. So I have to go and try some other options. What are my other options? Quadratic formula or completing the square. All right, let's go ahead. I'm going to complete the square on this one. That means I'm going to bring the 4 over to the other side. Okay, and what's the missing number that would complete that? We take half of our b term, so half of -2 would be -1, and square it. We get +1. So I'm going to add a 1 to both sides. I now have a perfect square trinomial. Whoops, x minus 1 squared. And on this side I get a 5. How do I solve that? Square root it. Okay. Now, what is the square root of 5, roughly? Square root of 4 would be 2, so it's going to have to be a little more than 2. Okay, let's just estimate it's about 2.2. Okay? What is 1 plus 2.2? 3.2. Did we have a 0 on our calculator that was between 3 and 4? Yes. What is 1 minus 2.2? Negative 1.2. Did we have a 0 just a little past the negative 1? Yes. So those are the two zeros that you're seeing. All right. That is the 1 minus root 5, and this is the 1 plus root 5. So they are real numbers. They're just not rational numbers. Okay. They're the irrational kind. So we have 3 zeros. The 1/2 we showed synthetically, and the other two, the 1 plus minus root 5, we showed using completing the square. What I want you to get as you're working through the homework today is that there are different options for finding the zeros. If it says to find them all and it doesn't give you a method, you have a lot of options. Synthetically, you should always be able to get a polynomial down into a quadratic so that you can use either a quadratic formula or completing the square to get the rest of them, whether they're irrational or imaginary. Okay? All right, I've got one more here. Go ahead and just put it in your notes packet or on the end of your homework assignment. I want you guys to try this in your groups. All right, so did you start this one by making a list? Yeah. All right, what does the list suggest? Positive and negative?
2, 4, 7, 14, 28.
All over 1. Okay. What did the graph show you? Positive and negative 2 and negative 7. All right, so let's go ahead and prove those. Make sure that you are looking for any missing terms. You need to plug zeros in for those. We don't have any on this one. I'll just go through in order. So negative 7, multiplying, adding, multiplying and adding, multiplying and adding. So that worked. Trying the negative 2. And that one worked. And trying the positive 2. And that worked. Yes? So we showed that they all worked. Did anybody try a different method besides the list, graph, suggest, prove, 3-step process? Nobody? Look back at your original question. There are 4 terms to it, yes? What's our only factoring pattern that works for 4 terms? The grouping pattern is the one we know. So, could we factor by grouping? If I had pulled out an x squared from the first 2, what would be left over? Okay, what can I take out of the second pair? A negative 4. Do I have an x plus 7 left over? All right, and then the pieces that we pulled out, the x squared minus 4, both of those things are getting multiplied to an x plus 7. The x squared minus 4 is a difference of squares pattern, so we can factor it further. And what are my zeros? Negative 2, positive 2, and negative 7. Same thing we got synthetically. Yes? So, just before I stopped the recording, I said, you have lots of options, right? If it just says find the zeros, if I don't give you any indication of what method I want you to use whatever you can. If it's factorable like this, I would have done that. If it's not factorable, then we go through the whole make our list, graph it, synthetically show they work. Yes? Now, obviously, if I told you find all the zeros using the synthetic process, you'd go through it with the first route. If I say solve by factoring, you go through with my second method. But if I give you the option, keep your minds open to what you have as options. Okay? All right. So we will be moving on to the second half of section 3.4 tomorrow. For today, you guys are going to do page 386, 9 through 16, and 39 to 49 odds.